the foundation of civilization. Our countdown begins with an invention so fundamental it literally carved civilization from the earth. For thousands of years, humanity scratched at the surface with simple wooden sticks. But medieval Europe faced a problem. The rich, clay-heavy soils of northern lands were too tough for ancient tools. The solution was the heavy plough, and it wasn't just bigger, it was smarter. Three components worked in perfect harmony. The coulter, a vertical knife that sliced through the soil like a blade through leather. The ploughshare, cutting horizontally beneath the surface. And the mouldboard, curved with mathematical precision to flip the heavy earth completely over, burying weeds and exposing fresh soil to air. But here's what makes this profound. This wasn't just about farming better. The heavy plough unlocked soils that had been useless for millennia. Suddenly, the dense forests and marshy lowlands of northern Europe became the breadbasket of the continent. Without this tool, there would be no surplus grain, no medieval cathedrals, no universities, no Renaissance. The heavy plough didn't just change agriculture, it made European civilization possible. And the engineering? Modern tractors still use the same three-part system perfected over 1,000 years ago. We've added horsepower, but we haven't improved the fundamental design. Sometimes the first solution is also the best. Eyeglasses, democratizing knowledge. Picture this, you're a monk in 1280, spending your life copying manuscripts by candlelight. By age 40, your eyes begin to fail. Your life's work is over. Then, sometime around 1285 in northern Italy, an unknown genius solved a problem that had plagued humanity since the beginning: age-related vision loss. Two pieces of carefully ground glass held in a simple frame. Eyeglasses. The technology seems almost laughably simple now, but the impact was revolutionary. For the first time in history, aging didn't mean the end of intellectual work. Scholars could continue reading, scribes could keep copying, knowledge workers had their careers extended by decades. But here's the deeper revolution. Before eyeglasses, literacy was largely a young person's game. The accumulated wisdom of older generations was trapped in minds that could no longer read new material. Eyeglasses changed that forever. Within a century, this simple invention spread across Europe, creating the first truly literate aging population in human history. The Renaissance? It happened because a generation of scholars could still read at 60. Today, over 2.5 billion people wear corrective lenses. That's 1 in 3 humans walking around with medieval technology strapped to their faces. And it's still the most effective solution we have. The three-field system. Long before sustainability became a buzzword, medieval farmers faced an existential problem. How do you feed a growing population without destroying the land that feeds you? The ancient Roman two-field system was brutal in its simplicity. Plant one field, let the other rest. But it wasted half your land every year, and even that wasn't enough to keep soil healthy. Enter the three-field system, a stroke of agricultural genius that changed everything. Divide your land into 3 parts. Plant one with winter crops like wheat. Plant another with spring crops like oats or barley. Leave the third fallow to recover, then rotate each year. The mathematics were beautiful. Instead of losing half your land to rest, you only lost a third. Production increased by 50% immediately. But the real genius was in the crop selection. Winter and spring crops used different nutrients and attracted different pests. The system naturally restored soil health while maximizing output. Here's what's remarkable. Modern sustainable agriculture is essentially rediscovering principles that medieval farmers perfected 800 years ago. Crop rotation, nitrogen fixing, soil conservation. We gave it new names, but the wisdom was already there. Industrial agriculture tried to outsmart this system with chemicals and monoculture. The result? Soil depletion, pesticide resistance, and environmental destruction. Maybe it's time we listen to the medievals again. The windmill post. Harnessing chaos. Wind is chaos. It shifts direction without warning, dies to nothing, then roars back with destructive force. For most of history, this made wind power a fantasy. How do you harness something so unpredictable? Medieval engineers in 12th century Europe solved this with an invention so clever, modern wind farms still can't match its adaptability: the post windmill. The entire mill house balanced on a single massive vertical post, allowing the whole structure to rotate 360 degrees. When the wind shifted, workers would push the mill around until the sails faced the breeze. Simple? Yes. Effective? Absolutely. But the real genius was in the internal mechanisms. A system of wooden gears and shafts transferred the rotation from the horizontal windmill axis to vertical millstones below. This required precise engineering to handle the massive torques involved, all crafted from wood with hand tools. Some of these mills ran continuously for 600 years with only basic maintenance. Compare that to modern wind turbines, which need computer-controlled systems to track wind direction and typically last 20 to 25 years. The post-windmill could be built and maintained by local craftsmen using local materials. It was renewable energy technology that was actually renewable. Not a bad lesson for our supposedly advanced age. The magnetic compass. Imagine being lost at sea with no GPS, no radio, no landmarks, just endless water in every direction. For most of history, this meant death. Medieval sailors solved this existential problem with a piece of magnetized iron floating in a bowl of water. The magnetic compass arrived in Europe around 1200, and nothing was ever the same. But the medieval version was more sophisticated than you might think. The compass wasn't just a needle in water. Advanced versions used a magnetized needle balanced on a pin inside a sealed glass sphere filled with oil. This dampened movement in rough seas and prevented the needle from being affected by the ship's motion. The principle seems simple. Magnetized iron aligns with Earth's magnetic field. But creating a reliable compass required understanding metallurgy, magnetism, and precision mechanics. Medieval craftsmen had to discover how to magnetize iron consistently, how to balance the needle perfectly, and how to create a housing that protected the mechanism from salt water and storms. Here's what's remarkable. Your smartphone GPS can fail, satellites can be jammed, electronics can break, but a medieval magnetic compass will work forever, anywhere on Earth, with no external power source. In an age of digital dependence, there's something reassuring about technology that just works, no matter what. The counterweight trebuchet. The starting point for our top 5 is inevitably the challenge of moving impossible weights with devastating force. Forget the simple image of a catapult powered by twisted ropes. That was a technology plagued by inconsistency, where power faded with every shot. The real challenge was this. How do you build a machine that can smash a stone wall from a quarter of a mile away, again and again, with terrifying precision, using nothing but the materials at hand? The answer, which appeared around the 12th century, was a testament to pure mechanical genius, the counterweight trebuchet, and its only fuel, gravity itself. Its principle was both brutally simple and deeply intelligent. Instead of fragile tension, the trebuchet uses potential energy. It's a massive lever. On the short end, a box filled with tons of stone. On the long end, a sling. A team would winch the long arm down, hoisting the impossibly heavy counterweight into the air, storing an enormous amount of gravitational potential energy. Then, with the pull of a pin, that energy was unleashed. But here's where the story gets truly fascinating. The true genius was in the combination of a hinged counterweight, a key medieval innovation allowing a more efficient vertical drop, and the sling, which multiplied the speed of the projectile like a whip. This wasn't just brute force, it was physics refined to a deadly art. By adjusting the counterweight or the sling, siege engineers could dial in their shots, striking the same spot on a castle wall until it crumbled. The legendary Warwolf, a massive trebuchet built by England's Edward I, was so psychologically terrifying, legend says the defenders of Stirling Castle tried to surrender the moment they saw it being built. So why is it on this list? Because in terms of pure elegant efficiency, its design is nearly perfect for its purpose. It represents the absolute pinnacle of mechanical artillery, a system for harnessing a free and utterly reliable force that was only rendered obsolete by a complete paradigm shift, gunpowder. We never surpassed it, we just changed the game entirely. Flying buttresses. From machines that multiplied destructive force, we moved to a place that commanded the elements of architecture itself. Look up at the ceiling of a Gothic cathedral. Then look at the walls, which seem to be made more of glass than of stone. What is holding all this up? For millennia, the iron law of architecture was that height required thick, heavy walls to counter the immense outward push, the lateral thrust of a stone roof. This meant buildings were inevitably dark and fortress-like. But Gothic architects had a revolutionary vision: churches that soared, filled with light. To do that, they had to solve the problem of lateral thrust while making the walls virtually disappear. The solution was one of the most elegant and visually stunning innovations in human history: the flying buttress. The mechanism is brilliantly simple. The buttress acts like a bridge for force. It catches the immense outward pressure from the roof, leaps across open space, and channels it away from the wall and down into a massive pier safely rooted in the earth. It's an external skeleton. That right there is a game changer. Freed from supporting the roof, walls could become thin curtains of stone and vast expanses of stained glass. This is what made the magnificent windows of Notre Dame and Chartres possible. And here's what makes this even more remarkable. The stone pinnacles that often top the piers weren't just decorative. Their weight pushed the pier more firmly into the ground, making the entire system even more stable. This was a perfect marriage of art and engineering, born not from convenience, but from pure, relentless necessity. Modern buildings use steel frames and reinforced concrete, but the Gothic cathedral did it with stone and an almost unbelievable understanding of physics. We don't often build with load-bearing stone anymore, but the principle of externalizing structural support is a cornerstone of modern design. The flying buttress solved an ancient problem with such genius that it turned structural necessity into a breathtaking display of lightness and grace. The Astrolabe, the original analog computer. We now move from the colossal scale of cathedrals to an object you can hold in your hand. But don't let its size fool you. This device was a smartphone, GPS, calculator, and clock, all rolled into one intricate package of brass, the Astrolabe. The problem it solved was fundamental. How do you translate the complex three-dimensional sphere of the sky into a practical, portable format? How could you create a tool to solve complex astronomical problems without tedious calculation, in a world without batteries or software? The solution, perfected in the medieval Islamic world and introduced to Europe, is a marvel. It is in essence a two-dimensional working map of the heavens. It has a body, the mater, engraved plates for different latitudes, and an intricate rotating star map called the Trebuchet. Its name means star taker. By holding it up and sighting a star with its ruler, the Astrolabe, you could determine the star's altitude. This one measurement unlocked a universe of information. By rotating the reading to match, you could instantly tell the local time, day or night, determine your latitude on Earth, or even survey the height of a distant mountain. For sailors in the age of discovery, simplified versions like the mariner's Astrolabe were vital tools for navigation, used alongside quadrants and other instruments. So, why can't we beat it? Because as an analog computer, its sophistication and utility were unparalleled for over 1,000 years. It's a physical embodiment of complex mathematics, solving problems of spherical trigonometry with its own mechanics. It's a computer that needs no power and has no software to crash, built from metal and intellect. When you hold a smartphone and open a stargazing app, you are holding the direct digital descendant of the Astrolabe. It represents a level of scientific mastery that utterly shatters the myth of a dark age. The mechanical clock. What time is it? For most of history, time was a fluid, natural thing, but the idea of the hour, the minute, a standardized beat governing all of society, did not exist. The invention that took time from the heavens and put it on a tower for all to see was born in medieval monasteries. The problem was necessity. Monks needed to observe a strict schedule of prayers, day and night, regardless of the sun or weather. Sundials were useless at night, and water clocks were unreliable. They needed a machine that was autonomous and mechanical. Sometime around 1270, the first fully mechanical clocks emerged. These were massive iron machines, whose only purpose was to strike a bell. The power source was simple, a falling weight turning a drum. But unchecked, the weight would just fall. The true genius lay in the mechanism that regulated its fall into steady periodic ticks. This was the escapement. The earliest version, the Virgin Foliot, is brilliantly simple. An escape wheel, turned by the weight, is caught and released by two small plates on a vertical rod, or verge. This push and catch motion creates the tick-tock, with each tick representing a small, controlled release of energy. This is why the mechanical clock is so profound. You could say it was the first digital device in history, breaking the smooth analog flow of time into discrete countable beats. Early clocks weren't very accurate, but that wasn't the point. Their very existence was world-changing. The clock detached time from nature and turned it into an independent mathematical quantity. The chiming of the town clock began to regulate civic life, creating a synchronized society essential for the rise of science, finance, and industry. You can't have the Industrial Revolution without a precise way to measure time. And that is why the mechanical clock is on this list. While an atomic clock is infinitely more accurate, the medieval clock wasn't just an invention that told time. It was an invention that created our modern concept of time. For fundamentally restructuring human consciousness, its impact is quite literally unbeatable. We're halfway through our journey, and what we've seen so far proves this era was anything but dark. These weren't disposable solutions, they were timeless extensions of skill and a deep understanding of the forces of nature. Hit like if this medieval ingenuity blew your mind, and let me know in the comments, which of these inventions surprised you the most? Honestly, I love knowing who's out there questioning how much we've really advanced. Your support helps us continue to challenge the stories we've been told and bring these incredible histories to light. Now, back to the countdown. The number one invention didn't just change how people worked, it represents a level of technological sophistication that remains an unsolved mystery to this day. The Gothic rose window. We arrive at number one with a technology so advanced, so mathematically perfect, that modern architects still struggle to replicate its genius. It's not a weapon or a tool, but something far more profound. The art of turning stone into light. Stand in front of Notre Dame, Chartres or Sainte-Chapelle and look up. What you're seeing defies everything we think we know about medieval capabilities. Massive circles of stone and glass, some over 40 feet in diameter, that seem to float impossibly in walls that should have collapsed under their own weight. The engineering challenge was staggering. How do you cut a giant hole in a load-bearing wall without bringing down the entire building? How do you support thousands of pounds of intricate stonework in a perfect circle, using only hand tools and mathematical intuition? The solution required understanding structural engineering, geometry, optics, and material science all at once. Medieval architects didn't just cut holes and hope for the best. They developed an intricate system of stone ribs, tracery, and buttressing that distributed weight with mathematical precision. Here's what makes this extraordinary. Each rose window is essentially a giant stone computer, calculating and redistributing structural forces through pure geometry. The tracery patterns aren't just decoration, they're load-bearing mathematics carved in stone. Every curve, every intersection point is precisely calculated to handle stress while allowing maximum light penetration. But the real genius was in the glass technology. Medieval craftsmen created colored glass, so chemically perfect, so optically pure, that we still don't fully understand their techniques. The blue glass of Chartres contains traces of cobalt, processed in ways that modern chemists are still trying to reverse engineer. The windows weren't just beautiful, they were light amplifiers. Medieval architects understood that different colored glass had different optical properties. They arranged these colors in patterns that didn't just tell religious stories, but actually manipulated how light behaved inside the cathedral space. Modern architecture has steel, concrete, and computer modeling, yet we build with materials that corrode, crack, and require constant maintenance. Meanwhile, rose windows built 800 years ago still function perfectly, still transform light into something transcendent, still leave modern engineers wondering exactly how they were made. The Gothic rose window represents the absolute pinnacle of what humans can achieve when mathematical knowledge, engineering skill, and artistic vision combine. It's not just a window, it's proof that the medieval mind could turn the laws of physics into poetry. And here's the ultimate testament to its perfection. When Notre Dame burned in 2019, the rose windows survived. 8 centuries of weather, war, and revolution couldn't destroy them. But it took modern restoration techniques and millions of dollars just to clean them properly. In an age obsessed with digital displays and LED screens, the rose window reminds us that the most advanced screen ever invented was made from sand, fire, and medieval genius. It required no electricity, produced no waste, and created beauty that has inspired humanity for nearly a millennium. That's technology we still can't beat. Conclusion. From the civilization-building heavy plough to the knowledge-democratizing eyeglasses, from the sustainable genius of the three-field system to the wind-harnessing post mill, from the satellite-free navigation of the magnetic compass to the raw power of the trebuchet, from the gravity-defying grace of the flying buttress to the pocket-sized universe of the Astrolabe, from the time-controlling mechanical clock to the light-transforming perfection of the Gothic rose window. These 10 inventions are powerful rebuttals to the lazy caricature of the Dark Ages. They show us an era of vibrant innovation where thinkers, armed with little more than their own intellect, solved profound problems with staggering genius. Their work laid the foundations for our time, shaping everything from our cities to our very perception of reality. The past isn't a dark monolithic block. It's a place filled with light, with ingenuity, and with lessons that still resonate. It reminds us that human creativity is not confined to any single period. So, which of these timeless technologies do you think had the biggest impact? Let us know in the comments below. Thank you for joining us. If you enjoyed uncovering these marvels, give this video a like and subscribe for more explorations into the history you were never taught in school. Until next time, keep questioning and keep exploring.